All right, welcome back, everybody. So as promised, I'm going to start right away with the impact ordering that I was surprised by the bell, so I didn't get it right. So here's what impact ordering is. It's yet another tool in your toolbox. We sort the terms by decreasing IDFs. Very rare terms, the best terms on the top and the stop words at the bottom. And we sort the documents right here by decreasing term frequency. Right, yes? Can you add me back? Oh, yeah. That happens. Now you're back. I need to make you a co-host also. Now you have all the rights. Perfect. All right. So you rank the terms by decreasing IDF, and we rank the documents, the postings, by decreasing term frequency, or also with this G of D plus TF IDF or whatever impact order you want, right? So the most important documents on the left and the least important documents on the right. What's going on here is going to be a bit different from what we've done before with the champions list. You know that we had the union and intersection to select documents. Now we don't care about the union and intersection and so on. We don't even care that the order is not the same for every term. And here's what's going to happen. We start here on the top left. If you look on the top left at these documents right here, these are the most important documents. This is a very rare term, and this is a very rare term occurring a lot in the same document. These are super important documents. And the more you go down and to the right, the less important the terms and the less important the documents. So the really, really fancy or like the best place is here. And if you go to the right or to the down, then it's less and less good, right? And that kind of gives you an idea of the hotspots that they are in there. Because the idea is that you can start here, go to the right, go down, and accumulate in your buckets for all the terms and the documents you see. But maybe at first you just start here, right? And then you keep adding until you get enough results, right? So of course, the only way you can do this traversal is term at a time, not document at a time. And that's again because the order is different for every term. So this is the reason why term at a time is the way to do it, but not document at a time. Right. But still, it's nice because term at a time works just fine to accumulate the document scores. All right. There's plenty of IDs actually in here. I'm just distributing the IDs here. There's another one that comes from machine learning. So this is why I'm not going to go too much into the details of that. But in machine learning, it's a clustering technique that you can organize your points in clusters, and each cluster has a leader. And then you can use that when you have a query, you just look at what cluster it is in, and then you look for the closest leader, and then you look for the leader of where it is, and then you return the documents that are in that cluster, right? So this is something you can also do in a slightly different way, and that gives you a subset of the documents, and you only compute the scores for these documents. You throw away the rest, you only compute the scores that are in there. Okay. Here's yet another idea that I'm throwing at you. It's called tiered indices. It's the idea that if we do this pre-selection, it might be that we don't get enough output documents. Maybe we were too restrictive in the way we pre-selected the set and we don't have enough results. So what you do in that case is instead of having just two lists like that, you basically come up with 3 or more lists. So you basically separate your documents in several classes, and you build several indices, tier 1, tier 2, tier 3. You basically have tiered indices. And then you start with the tier 1. If you have enough results, then that's fine. If you don't have enough, you go to tier 2 and add more results. If you still don't have enough, you go to tier 3, and so on and so on and so on, right? So these are called tiered indices, and it's just that you just keep going to lower and lower and lower tiers for as long as you don't have enough results. Okay. Something else that can be used for scoring is the proximity. For example, here you have ETH Zurich in your query, and you have in the text both words that you're looking for, ETH and Zurich. But you see that the distance between them in that case is 4. It's a window of 4 words, 1, 2, 3, 4. So there's a distance of 4. In another one, you might have a distance of 7. Of course, this has nothing to do with ETH Zurich. It's about Ethereum cryptocurrency and Zurich, the city, right? So what you can do is that, and this is one about ETH Zurich. So you can use that as a score, right? That's 7, 4, 2, and so on. And then you rank and pick the lowest distances. So that's yet another way of organizing the ranking of the results, right? And if you take the top 2, for example, then these are the 2 that you return, and this is fine. This is what people are actually looking for. All right. So now let's zoom out a little bit of everything we've been doing since the beginning of the semester. We, in fact, look at plenty of different languages for querying information. We looked at Boolean queries. This is where we started at the very, very beginning, right? So we started here with and, or, not, and so on. We looked at phrase queries. This is where you add the quotes. We also saw the structures that there is for that. What are the structures for phrase queries? What can we use instead of the standard inverted index here? Yes, byword indices. Something else? Byword index is one of the possibilities, yes? Positional indices, exactly. So these are 2 of the ways that you can implement that. Wildcard queries, how do you implement wildcard queries? Anybody remembers? Yes? Yes, we use exactly these. These are the search structures that we used. So that's the left part of the index. And what do we put on the right of the B+3? So or at the leaves of the B+3? Do you remember that? Yes, exactly. For example, you have the k-grams that you can use also for spell checks. And I'm also thinking of the permuterm index, right? When you rotate the positions of the indices, the k-gram indices are also what you can use. So absolutely, we looked into these structures, right? Zone queries is what I told you was the first attempt to get ranking using a more relational database-like approach with relational columns. And we also looked at queries. So this is a more natural way than the Boolean query. It's basically the Google/Bing/DuckDuckGo and so on approach where you just type words in a box and the search engine figures it out, right? So maybe it's going to just do some, I don't know, post-processing of the query to figure out if it takes it as a phrase, if it takes it as a Boolean query. So of course, nowadays the systems can become quite complex, right? But you can do queries like that. All right. Also, the most obvious way is the vector space model. You basically build a vector and you use the vector space model to do ranked retrieval. All right, and now I even put back inverted index by word. Positional index would be here too, k-gram, permuterm, zone indices, and so on and so on. So you see, these are all the ways that you can interact with the system. It's quite impressive, right, with what we've been doing since the beginning of the semester, like all these ways of running your queries. So what does a complete system look like then? When you have your collection that you want to index, it can be the internet, it can be the books in a library, it can be a set of documents that you downloaded and stored somewhere or in the cloud. You parse, you do the linguistics, all this language preprocessing, the stop words and so on that I told you about. And then you index and you build the indices. So typically, you're not going to build just one index. Why would you build just one index? You can build plenty of indices. So you can build zone indices, in exact top K retrieval indices with this top R, champions this, and so on. Tiered. So here it's basically the ultimate like tiered inverted positional index. You basically use the tiers plus you use the positions, right? So it's the positional index. So you see you can mix things together. You can use a byword index for phrases, a k-gram index for spell checks and wildcards. So basically you build plenty of indices. Which ones? There is no absolute answer. It depends. You just pick a few and build the ones that you think you will need, right? Or you can add more later and so on. But basically you have your collection of indices. and they are ready in order to be used to do queries. So the query arrived. This is then the runtime. So this was at compile time, kind of, right? It's statically. So you download your set to index in advance. And now it goes in production and the user starts querying. So you parse the query, you do spell checks if necessary, and then you use the indices in order to find out the documents that are the answers to your query. So in the case of Boolean querying, it's just returning the documents. But we saw that in the case of ranked retrieval, where we had the vector space model, we need to compute the dot products. So what happens is this phase, there's a fancy word for that, it's called evidence accumulation. So what is evidence accumulation? Where it's this part where you do this term at a time or document at a time traversal, left to right and top to bottom, and you just accumulate the scores in the buckets. You're basically computing the dot products. This is called evidence accumulation. Right? So you go through the indices, accumulate the evidence, accumulate the scores, and when you are done, then you can sort the documents, or more exactly, extract the top 10, linear instead of n log n. Use some weights if necessary, right? You can also weight the different parts of the system to attribute a score. And then you rank and you return the results to the user. This part here is that it's very common when you return the results to the user to also include a snippet of the documents. So if you cache the documents, that's what happens on a search engine. You include the paragraph around the words that you found, and then to the end user, you return the snippet with the highlighted words, right? It's a common way of doing that. So this is why you might also want to cache your documents and return them, right? This is what a typical search engine is doing. Then right here is also something you prepare in advance. This is the machine learning part where you can actually learn the weights, the best weights for your system out maybe of a training test. So I'll tell you more a bit about that and how to evaluate all of these things. And that's pretty much it. So you see, that's the overall architecture. And now with everything we've been doing in the previous few weeks, now you basically understand more or less what's going on everywhere in there on the high level. So you would be now in a position that you could build a system like that. You could assemble your components, pick your components, and build something. And again, I repeat, very important, there is not one way to do it. There are plenty of ways to do it, and it's all about design decisions that you make in order to build the system, right? So this is the end of part 8 of the lecture. So I will start because it seems that we have time, the part after that. Do we have any questions? Anything that you want to ask about this lecture, about previous lectures? Yes? Yes, I can, or maybe we can use the microphone. Always a good idea. So that people who are on Zoom can also hear.
I was just wondering if the training set should at least be somewhat dependent on the document collection. That's what I wondered.
Yeah, absolutely. I think it would be, in general, it's again a design decision. You could consider that your training set is a sub-part of the document cache, or of the document collection. There is also a historical perspective, in fact, on that. I will also say a few more words on the evaluation part. Historically, in the same way that there was this very early system, SMART, that basically ignited a lot of what happened in information retrieval, starting, I think, in the 50s, 60s, 70s, there is a whole community for information retrieval that started emerging. These people started organizing small conferences, small working groups, conferences, and started gatherings. And the goal of these gatherings was to create sets like that, training sets. So it was not necessarily to create the actual set of what you want to index, right? So the actual internet or the actual collection that you want, but they created specific training sets. One of the very early ones was on aeronautics, basically on the rockets, planes, and so on and so on. This was one of the very early sets with publications that they started to index. And they were very interested in using these smaller training sets in order to bootstrap evaluation, to basically be able to say, is my system a good system, right? And here, you basically, what you see here is the 2022 perspective, because we know machine learning, we know how that we can train things and so on. Back in the 60s, that didn't exist. But what they tried to do is at least find criteria to estimate if a system is good or not, right? And in that sense, people could also argue on the opposite of what you said, say the training set can also be something separate. In that case, that could be called, it's called, one was the Cranfield track and so on and so on. And these were used to provide an evaluation of your system. So you might have basically, let's call it the production part of the system, that is the actual documents. And then you have a part that is called, maybe for evaluating your system, that is not necessarily what you intend to index for your customers, but that is basically required for estimation, that you basically use your system on that set and then evaluate. Right. I'm not sure if I answered completely your question or, yeah, all right, perfect. Anybody else? Any other questions? Anything that wasn't clear? Anything you didn't understand? Note that even if you don't ask today, you can ask in other weeks, right? I am always here to answer questions. Nobody else on Zoom? Is anybody on Zoom wanting to ask?
I think the slides are not on this year for the slides.
Oh, really? I think I checked. They are? Or maybe not now.
I'll check.
Yeah, because I sent them yesterday for putting on Moodle.
Okay, sorry.
Yeah, if not, we will check that it is in any case. But the 9, I'm not sure if I sent the set of slides for the 9. Can somebody look on the Moodle if the set of slides for evaluation is on the Moodle? So this one normally is the one we've just done, right? But the one on evaluation? No? Okay, yeah. So let me take 1 minute to share the link. Then I'll make sure that everybody has this, the next set of slides. All right, so I'll just say goodbye. I'll stop the recording, and then in 2 minutes, I'll start again with a new set of slides sharing it. So see you on the other side.